Hello, ladies and gentlemen. It's time for a little overview of the exponential and linear review number 2. We've been working with linear and exponential functions a whole lot. You need to be able to identify initial value, also known as y-intercept. You have to be able to get the slope if it's linear, and you got to be able to get the growth factor if it's exponential. So a few things to remember. On the linear equations or exponential equations, often you see y equals, and that's the same as f of x equals. And then it's of the form mx plus b. The m is the slope, and then the b is the initial value, or y-intercept. We have multiple names for that: initial value, y-intercept, starting value, all those sorts of things. So we need to be able to write the initial value and slope for each line. So we're just going to have slope is -5/2, and then our initial value is going to be 5, right? Initial value, slope. So just write them out, and that's what's going on in a lot of these. If you're looking at a graph, this is going to be your initial value. And then to get slope, you need to find 2 distinct points, and then get your slope. In this case, it went right 2 and down 3, so -3, which means our slope on it is going to be -3/2. Remember, the top part tells you how much it goes up and down, and then the bottom number tells you how much it went sideways. So it's up and down, and then sideways is the bottom number. So those control those aspects of it. Okay, so that's what's going on there. It has a couple questions here where you need to do certain things with slopes or initial values and things like that. When you have exponential functions, you need to remember what things do what. Once again, y is the same thing as f of x, and our format is a times b to the x power. The a is your initial value, also known as your y-intercept. The b is your growth factor, which I usually just write, factor. Growth factor, which I just often just say GF for that. And so on number 8 here, our initial value is going to be the 1/3, and then our growth factor is going to be the 6. Okay. When you're looking at a graph, say number 10, and you realize it's this curve, so it's going to mean it's exponential. If you don't have a clear y-intercept here, that's a bit hard number to know what it is. Do find numbers that you can identify. So I see a 1 here and a 4. Looks like up here something around 16. It helps to get numbers that you do know and figure out what the pattern is. Okay, 1 to 4, that's timesing by 4. 4 times 4 is 16. Okay, this is timesing by 4. So if I want to go from 1 to this number here, instead of times by 4, I'm going to divide by 4, and 1 divided by 4 is, that's already a number we know. It's 1/4. So that's going to be right here. 1/4 is going to be this point. Okay, and so that gives us our initial value of 1/4. And we already found out what it's timesing by, so our growth factor is going to be 4. So there you go. So if it's a little bit tricky, find points you do know, and then use some logic, work your way through to find points you don't know. And again, 11, 12 are just kind of more thinking kind of questions where you have to explain some different things, make things up. On problem 13, you're confronted with 4 different situations. You need to say whether it's linear or exponential, and then write a function to model it. So that's what we did on our level 1 and 2 tests for this. You need to be able to figure out what's going on and go from there. So for instance, situation 1, Farley leaves $5,000 in an account and earns 5% a year. That is a big hint that it is exponential, and it is exponential. So I'm going to write out our function, f of x equals, and once again, it's a times b to the x power. Often we just do parentheses like this. A times b. A is the initial value, b is what you're timesing by. In this case, it starts with $5,000, and it's timesing by something. If you're earning 5%, you're increasing by 5%. So think about what number goes in our parentheses. What do you times by to increase by 5%? hopefully you realize that if you increase by 5%, you start with 100%, start with add on 5%, now you're looking at 105%. Lots of percents here. Now you're at 105%, and we're going to put that in here, but when you put it in there, you do need to put it in decimal form. So you're going to put 1.05 like that, and voila, we have an equation to describe that exponential situation. So there we go. And then on this last section here, on problem 14, you're confronted with a bunch of tables. You need to be able to identify the linear and exponential and identify the initial value and or slope or growth factor. Let's go to D. Let's see here. We got a... No, this one's a little weird. Right here it's adding... Well, it's subtracting 4. Subtract 4. And then here, it looks like it is subtracting 8. And then this one, it's subtract 2. This isn't even consistent. Well, when you're looking at patterns and tables, you do have to look at the x's as well. And the x's in this case are not adding the same thing each time. So we got plus 2, plus 3, plus 1, and then plus 2 again. And so this might be linear. It might be exponential. We got to look over equal values here and see what we get. So if we look at this first section, it subtracted 4 as it went right 2. So we got a slope looking like -2. Oh, sorry. This one here is not 3. That one's 4. Okay. This one, it went down 8 as it went right 4. So subtract -8 over 4. Oh, that one also comes out to be -2. Okay. Oh, that one comes out to be -2. That one also comes out to be -2. So all along this one, it does come out to be -2. Consistent change there. It's just over different x's. And so that one is going to be linear. And we know our slope in this case is going to be -2. We already figured that out. But we also need to figure out the initial value. In a table, the initial value is when x is 0. But here we don't have any x's being 0. Up here we do have it, like on A, our x value is 0, so the -3 would be the initial value. And on B, again, x is 0, the initial value there is going to be -3. But on these two tables, we don't have the initial value. And so we had to use the pattern to figure out what it's going to be. So going to the right here, each time you go right 1, it's going to subtract 2 on the y's. And so if we go back 1 here, get to 0, we'd have to subtract 1, which means here we would have to add 2 if we're going backwards. Going to the right was subtracting 2. Going left is going to add 2. And so our initial value is just going to be -11, which is going to be -13 plus 2. So there you go. Sometimes the table's a little bit tricky, but you can figure it out. You just get used to it. And that's what's going on in the review. Lots of different problems. Get initial value, get slope, and get initial value, get growth factor. You just got to get really used to those things.